All right, so we're at 25 now. Certainly, I'm going to go through the word problems now, but I think the key with the word problems, you can certainly solve an equation. So when I read these word problems over here, I'm just going to write the equation down. Right, then you solve it, make sure you're okay with that. Right, so it says the total cost of painting a house is $1,346. And they say that cost comes from $125 in material and some labor. And they say the labor is $33 per hour. I'll say H is the number of hours they worked at it. What's your question? How many hours of labor are required? You solve for H. And if you do that, you get 37. All right, let me look at number 12. I'm sorry, not number 12. I don't know why I said 12. Actually, I do know why I said 12. It's a 12-foot board. 26 says a 12-foot board is cut into two pieces. So if I cut into two pieces, I'd say one of the pieces is X feet long, and the other one's going to be 12 minus X feet long. All right? Now it says, it says a 12-foot board is cut into two pieces, and it says twice the length of the shorter piece. Well, you know what? I got to say one's the shorter piece now, and I'm going to say that X is the short piece. This is the short one. All right? So let me write this one down. What does it say? It says twice the length of the shorter piece is 3 feet less than the length of the longer piece. Well, what's the length of the longer piece? 12 minus X. This is the equation. Now again, the equations are written over here. I'm use different letters, but I did do that. And if you solve that, you should get the short piece to be 3 feet and the long piece to be 9 feet. Again, if you're trouble solving equations, you shouldn't be doing word problems. You should be trying to solve an equation. All right, so the perimeter of a rectangle is 26 meters. The length of the rectangle is 1 meter. Well, you know what? I'll put a rectangle down. And this is the width, and this is the length. So I say the length of the rectangle, right? The length of the rectangle is 1 meter more than twice the width. Okay? Find the length and width of the rectangle. Well, you know what I know? I know the perimeter is 26. So it's going to be 26. And it's going to be two lengths. So 2 times 2W plus 1. And it's going to be two widths. Now again, this equation is written over here. And again, if you solve that, you'll get W. And then you can figure out L. The W would turn out to be 4. And then you can get the L by using the relationship that we had. And what's the L going to be? Twice W plus 1. All right? So let's take a look at number 28. And 28 says the perimeter of a triangle now. Now, granted, some people reading this, they think it's rectangle, but the key word is a triangle. Right? There's 3 sides to that. Now, again, it's a little complicated, but it says that one side is twice the second. And I know there's 3 sides. Right? So let me put down there's 3 sides. Side 1, side 2, side 3. So I'm going to say first side. The first side is, well, let's write the second side down too, because they're going to talk about that, aren't they? And they're probably going to talk about the third side, I bet. So it says one side is twice the second. Well, the second side I'll just call X. It says the third side is 30 inches more than the second side. Well, the second side is X. Find the length of each side. Well, you have to add these sides together. So first side, 2X, plus the second side, which is X, plus the third side, which is X plus 30, has got to be 110. All right, then you solve for X. All right? I want to point out the equations are written over here for you. And the solutions are written down as well. You want to pay attention to that. All right, another rectangle problem. The width of a rectangle is 5 feet less than its length. I'm going to draw my rectangle down. This is width. This is length. It says the width of the rectangle is 5 feet less than the length. Now it says the area. Now what's area? Area is going to be the length times the width. So the length, I'll write this down, length times the width. Well, what's the width? The width is length minus 5. They say the area is 176. That equation's here, and you'd have to solve this equation. And again, they give you the answers to it. All right, now this one, it's always a scaling problem, and I'm hoping when you're reading this thing, you're not too adverse to these numbers over here. But they say on a map, two cities are 2 5/8 inches apart. It says 3/8 of an inch on a map represents 25 miles. All right? So what I want to do is, and again, I realize there's work down over here, and this is really not like an algebra problem as far as I'm concerned. You could write it as an algebra problem, but I'm going to write this as an improper fraction. All right? Now, what I mean by that, I'm looking at that, and, 8 times 2 is 16, right? And 16 plus 5 is 21. And I'm going to write this down because I want to get 3/8 out of it. And what times 3/8? It would be 7, right? So you should know that every 3/8 of an inch on a map would be equivalent to 25 miles. And how many do I have? I have 7 of them. And what's 7 times 25? Well, let's see. That's 175, right? So 175 miles. Again, I don't see it as an algebra problem. Okay, this is a uniform motion problem. Distance equals rate times time. It says a car leaves town traveling 40 miles per hour. 2 hours later, a second car leaves the same town, the same road, traveling 60 miles per hour. So he's chasing the guy. In how many hours will the second car pass the first car? All right, algebra must be used. So, in how many hours will the second car? Well, the second car has been traveling for 2 hours. And the other guy is going 40 miles per hour. And they'll catch up. That means they go the same distance. He's got a 2-hour head start, doesn't he? So it's t plus 2. That's right over here. Now, granted, I know we're going faster to the word problems. And don't worry about it. When you get to 100, which you're in now, you just look for prerequisites. A lot of it's repetition. You'll see these problems over and over again. They keep repeating them over and over and over again. All right, with the hope that you're going to catch on at some point. So 2 cars, one traveling 10 miles per hour faster than the other, start at the same time and from the same point and travel in opposite directions. In 3 hours, they're 300 miles apart. So let's take a look at it. And I'm going to, put down that 2 cars, one traveling 10 miles per hour faster than the other. So the rates are going to be 10 plus x. That's the rate of one guy. And the other guy's going to x miles per hour. And it says in 3 hours. Well, let's write this down. Rate times time. Rate times time is going to be equal to what? 300, right? That's the equation, and the equations are over here. All right, I used x instead of the rate, by the way, and that's fine. All right, solve it. All right, sales tax on a car that sold for $12,000, $780. That's not bad. At this rate, how much higher is the sales tax on a car that sells for $13,500? Well, I kind of see it as a ratio problem, that $780 in tax on a $12,000 car. Their question is, how much more tax would you have to pay? Well, I don't know. On a car that's $13,500. Now, that's one way to do it, and that would be an equation. You solve that, and I'm hoping you get the number that we're telling you you're going to get. All right, now we're getting to these graphing problems. I'm going to say graphing's relatively simple. These are lines under their form y equals mx plus b. And your teachers may have done these the right ways. I'm going to say that one of the good ways of doing it is just use your finger numbers to get a table of values that are simple. And they're lines, so you just need 2 points. So I'll say x is 0. When x is 0, you get 1. And I'm just plugging in here. The next number I choose is 3 because it's easy. Now, if you chose 3, what would you get? You would get, let's see, minus 2 plus 1, which is minus 1. I'm going to graph these 2 points for you. And 0, 1's right here. And 3, minus 1's right over here. And then what do? You draw a line through those points. Now, somebody say, oh, you're drawing over your graph. You're not kidding, I'm drawing over my graph. And again, graphs are there for a reason. We'd like you to look at those and learn from those. Let's do this one over here. And it's going to be, 2 points. And let me put the 2 points that I believe that are easiest. I like to use finger numbers if I can. I'm going to say x is going to be 0, and the y would be minus 2. It's super simple if they're simple numbers, and they really are. If the y is 0, the x would be 4. Well, let me graph these out, and 0 minus 2 is here, and 4 zeros over here. and draw a line through those 2 points. And yes, I'm drawing over my picture. This one's a little different. It says x equals minus 2. And what does that mean? It's still a table of values. I'll put it down for you. It's a line. X saying it's a line. So x has to be minus 2, but y can be any number you want. So I'll put these numbers down. Y can be any number. But what does it look like? Well, let me draw this and not look at the picture. So minus 2, 0. I get that point. And minus 2, 1. And I got that point. What kind of line are we getting? We're getting a vertical line. Look at the key, and I see that. All right, they got the point. Okay, let's do this one over here. And what does this one say over here? It says y has to be 3. X can be any number in the universe. Okay, let's take a look. 0, 3, right there. And then I said 1, 3, right there. And there's a line that goes through those 2 points. Looks like this. That's about it. I think we're done. And again, I know it's tough, and it is tough. Don't worry. I realize this over here, they say it's a prerequisite. It really is. But Math 100, I got to be honest with you, there's very little new material in Math 100. I mean, the new stuff you're going to see in Math 100 are going to be, you're going to see the quadratic formula. You're going to see completing the square. These are new topics. By the way, these two are very much related. You're going to see, what else you're going to see? You're going to see parabolas. This is the new stuff. And you're going to see circles. And that's really it. I mean, when you think about it, and by the way, they're all related to that quadratic and completing the square. They're really all related to the same thing. And again, this is the new stuff. It's new. Now I'm thinking, maybe I'm not thinking clearly, but I think that's about it. So all the stuff here that we just reviewed here, they'll review it again and again and again. And I kid you not, they'll review all that stuff again and again and again. So I realize you might say, oh, you went really quickly through that. And yeah, I did. I know I went quickly through it. But here, don't worry if some of this stuff looks really bad to you. They'll keep repeating it. And I mean that. They'll keep repeating. Does repeating work? I don't think so. What does work, though, is if you get busy working on problems, doing more and more problems, it does work. So please hang in there.